This far we've discussed angles that are either in the circle or on the circle. Well, there are also angles that are formed outside the circle that pass through it that have a special relationship with the circle and the degrees being cut off. So here are the three different types of angles you could find outside the circle. You might run into a secant-secant angle, which again, very aptly named because it's created by a secant DC and a secant FE that meet outside the circle over here at point G. So that's what we mean by a secant-secant angle. You could have a secant and a tangent run into each other. So AB is a secant because it goes through the circle, but DC is a tangent because it only hits one point on the circle. They intersect each other out here at point C, so that would be a secant-tangent angle. You could also have two tangents run into each other, such as tangent QR and tangent SR, which is going to run into each other at point R, again, outside the circle. So we do call them tangent-tangent or secant-tangent or secant-secant angles, but for the most part, all you need to understand is if these angles are created outside the circle, they all have the exact same relationship. And that relationship is this. The measure of a secant-secant angle, a secant-tangent angle, or a tangent-tangent angle is equal to half the difference of the two intercepted arcs. So let's see what I mean by that. On example number 1, I have a secant-secant angle, and I'm looking for the measure of that angle, DGF. So if I follow this angle through, so D to G to F, when we talk about the intercepted arc, you'll notice that there is two of them to choose from. This angle cut off this 40-degree arc, and this angle also cut off this 90-degree arc between those rays of the angle. So what this theorem says is I'm going to take half the difference. Well, it wouldn't make sense to start with the 40 minus the 90. I'd get a negative number. So it's the measure of the big arc minus the smaller arc divided by 2 will give me the measure of that angle that is outside the circle. So in this case, I'm going to get 50 divided by 2. So that measure of angle DGF has to be 25. The next example is the exact same thing, but it's created by a tangent and a secant. You don't have to worry about that. All you have to recognize is that angle ACD is outside the circle. And when I'm outside the circle, I'm going to cut off one arc and a second arc, and the measure of my angle will be the larger intercepted arc minus the smaller arc divided by 2. So in this case, I'm going to get 60 divided by 2, so this must be a 30-degree angle for angle ACD. Third example, nothing new here. It's a tangent-tangent angle. All I care is, hey, this is outside the circle. So if it's outside the circle, I'm cutting off one small arc. I'm cutting off one big arc. So it's going to be the big arc, 230 degrees, minus the small intercepted arc of 130, and then half of that difference. So I'm going to end up getting 100 divided by 2. That's a 50-degree angle sitting outside my circle. Well, there is a unique thing that happens with the tangent-tangent angle. If you look at the next example, I didn't give you all of the measures of the arc. All we see is that, yep, this is outside the circle, and I have the big intercepted arc is 260 degrees. So it's 260 degrees minus the smaller arc divided by 2. But what is that smaller arc? Well, this is the unique thing about a tangent-tangent. A tangent-tangent angle ends up intercepting the entire circle. Your small arc over here connects with your bigger arc, 260, to create the full 360 degrees of the circle. So if I take the 360 from the whole circle minus the 260 of the big arc, I should know that this is actually a 100-degree arc, and I can proceed like normal. So I'm going to have 260 minus 100 degrees, which is 160 divided by 2 is 80 degrees for that angle. So angle XYZ is going to equal 80 degrees. Now if you look at those two numbers, there's a unique relationship here. The angle was 80 degrees, and the arc right next to it was 100. Well, when you add 180, you get 180, which means those two numbers are supplementary. So we get a very nice theorem that says if you have a tangent-tangent angle, it's always supplementary to the smaller intercepted arc that's right next to it. So I'm going to jump to this second example over here because that's exactly what I have. I have a tangent and a tangent creating this angle XYZ. So that means if arc to XWZ, so arc XWZ is 235, what is the measure of angle XYZ? Well, if I can do 360 degrees minus 235 to figure out what that missing arc is, that's going to leave me 125 degrees for this minor arc. So I could do the big arc minus the small arc divided by 2, but I know that since this is a tangent-tangent angle, then the smaller arc of 125 should add up with this angle to be supplementary or equal 180. So 180 minus 125 means that that angle has to be 55 degrees. So you have options. This is only for a tangent-tangent angle. A secant tangent or a secant secant angle doesn't work that way, and let me show you that. On the first example, I noticed that this is a diameter, so I do know that all of this intercepted arc is 180. And if I already have 100 degrees of that taken up, this small intercepted arc right here is only 80. So this angle is what I'm looking for, angle DCA, which is outside the circle. So I know that it should be the big intercepted arc of 100 minus the 80 degrees of the smaller arc divided by 2, which is going to end up being 20 divided by 2, which is 10. So you'll notice this angle is 10 degrees, this angle is 80 degrees. That's not supplementary. That's only going to work for the second example here when it's a tangent-tangent angle. So be careful with that. So now you have all the theorems. What I want you to do is try and do these examples, see if you can find the answers, especially on a more complicated picture such as this. This is what you can expect to see on your test. So the third video will show you the answers to all of the extra examples that I have not yet done. Try them. If you can't get them, watch the video, check your answers, and if you can't get that, see me, ask me some questions.